Factoring by grouping or higher order factoring would probably be a better title for this tutorial. Regardless of what type of factoring you're doing, you should always first look for a GCF. That should be your number one check. If there's not a GCF in the entire polynomial, then you look to see how many terms you have. Do you have 2 or 3 or 4? And then go forward based on that so that you can factor. If there are 4 terms, then you are going to try factoring by grouping after you have originally looked for a GCF in all 4 terms. So here's an example on the front page of grouping. You're going to choose 2 groups. I would start out by choosing the first 2 terms and the last 2 terms and divide them into groups. You then factor out a GCF from each individual group. So just looking here at group 1, find the GCF. It would be a squared in this one. A squared is the highest quantity of anything that both of those terms share. I can take an a squared away from both of those terms. When I take a squared away from 2a to the third, I'm left with 2a. Bring down the subtraction. When I take a squared out of a squared b, I'm left with b. And to do a quickie double check to see if you've done everything correctly, take this a squared and distribute it. A squared times 2a would be 2a to the third. A squared times negative b would be negative a squared b. So that's a quick way just to make sure that you have factored out the GCF correctly. And then you're going to go forward to the next group. In the second group, we're going to do the same thing. Let's focus here on this second group. Find the GCF between those 2 terms. We could factor out the number 5. Factoring out the number 5 means I would have 2a left here. Bring down subtraction. Factoring a 5 out of 5b would leave me with b here. So notice now in my groups, I have a common factor here. I have 2a minus b and also 2a minus b. That should always happen. That means that is a common factor. If you do not get the same common factor inside the parentheses for both groups, then it's not going to work to factor in this way. You would have to go back, possibly try to switch groups, mix up the groups, or it may not work at all. So now that I have found that these are in common, then this is our common factor here, 2a minus b. And the GCFs that I pulled out of each group, this and this, a squared plus 5, that is going to go here, a squared plus 5. So this would be my answer. This would be completely factored. You just double check inside each set of parentheses and make sure that there's nothing common in either of those sets of parentheses. And then this would be your final factored answer. If you are unsure and you want to check, you could take what you think is your final answer and use FOIL, first, outer, inner, last. You could multiply here, and you should end up with the beginning polynomial. That way you could always check if you want. Okay, so let's go forward and look at some other examples in the packet. If you'll look here, this is page 2 in the factoring packet, and it's just notes, the steps on how to factor each of these things. Difference of squares, difference of cubes, sum of cubes, and then factoring by grouping. So here are some steps if you want to come back and take a look at those at any point. I'm going to go directly to the factor by grouping section, and then I'll go backwards and do some of the others. Okay, so here's my steps. Everything that I described is written into words right there. Check for a GCF. So let's do number 1, and there is no GCF among the 4 terms. Altogether, all 4 of them do not have a single factor that is in common in every single term. So now what I'm going to do is break into groups. I'm going to take that negative with the x. So I'm going to put this in here, and then we can add in between the 2 sets of parentheses. So first set GCF is x squared, leaving me with x plus 3. My second set is negative x minus 3. Knowing that I'm trying to get my common factors alike, knowing that this is what I want to have inside my parentheses, excuse me, I'm going to factor out a negative 1. So if I factor out a negative 1, then that leaves me with x plus 3 inside the parentheses, which is my common factor here. So now let's pull the 2 GCFs that I factored out from each group. That's going to be my first set of parentheses. And then my common factor x plus 3 that both of them had left over, that's my second set of parentheses. So this is where I check to see, am I finished, or do I have something else that I can do? If I'm finished, I put a box around it. But it looks like here in this first set of parentheses, I have x squared minus 1. And x squared minus 1 can be factored some more. That's not completely factored. That's actually a difference of squares. So I'm going to need to take this set of parentheses and go further. I'm going to factor further. X squared minus 1 is a difference of squares all on its own, and it factors into x minus 1, x plus 1. So I have to do that. Now I'm just going to bring down the x plus 3 because that's still part of my answer. And here's the part where you just have to do your multiplying and check. If you are not sure if you've done it correctly, then you'll want to do a check. You'll want to multiply these 3 sets of parentheses together. Use FOIL a couple times to double check. So that's something you definitely in higher order factoring need to look out for, because it happens quite often in higher order factoring where you'll think you're finished with one part, but then what's inside that parentheses can continue further. Problem 2, I'm starting out by choosing these 2 groups. And the only reason that you would want to choose different groups would be if the way it's given doesn't actually work out. Now, hold on a second, because I see I was about to dive in without going through the first step that I should always do no matter what. So here's a good example of how you've got to always make sure you do this. You want to check for a GCF among all 4 terms. I mean, it seems like I'm saying GCF an awful lot, and I am, because that's kind of the whole process. You're looking to find what's common, and then you're dividing it out. Now, all 4 terms here, it looks like they all have at least one x that could be factored out. So that's going to be important. So I'm definitely going to factor an x out of all four terms. And then let's look at our coefficients. 624, 520. There is not a coefficient that can be factored out, but I can factor out this x. So let's do that. Okay, very important. Okay, glad we caught that. Now let's go ahead with our grouping. Let's pull together the first two and the last two in our groups. Now the x that we factored out, it's going to go with us in the end, so don't forget it. Make sure we remember it's here, highlight it or something so you don't forget. But now with what's inside here, these two groups, let's go forward. First group has a 6 in common and an x squared. So I'm going to take 6x squared away from 6x to the third. I'm going to divide it out of 6x to the third. 24 divided by 6, and then x squared divided by x squared. Okay. Last set, 5 is in common. And keep in mind, out in front of all this, we still have our x. So don't forget that. All right. Common factor here. So x plus 4 is part of my answer already. And then I take the two GCFs I pulled out to make my next set of parentheses. And then don't forget we have this x out here that still needs to be part of the answer. Don't forget about him. Now carefully look into each set of parentheses and make sure that we haven't left anything in common inside each set of parentheses. So before you put the box around your final answer, look inside each set of parentheses and make sure there's no coefficients in common and there's no variables in common at any spot. And if I want to check, then I can use FOIL and then distribute. So I would multiply to go backwards and check. Okay. So let's keep going here on this same page, higher order factoring. Let's take a look at what we have here. Higher order means that it's going to have a higher power. It's going to be x to the third or x to the fourth, maybe even higher than that. Step 1, I always look for a greatest common factor in every term, and there's not one. Second step, I count how many terms I have, and I have 1, 2, 3. I have 3 terms. According to my flow chart, 3 terms is a trinomial, and that's when I'm factoring like CAB or a box method. So whichever is your favorite, regardless, you will multiply the first and last terms together. Multiply the first and last terms, so 6x to the fourth. And then you look for 2 factors I can multiply to get 6x to the fourth. I need to multiply them together to get 6, and then I need to add them together to get -5. 2 numbers I could multiply to get 6 and add to get 5. The 5 is negative. The 5 is negative. This number is positive. So that means if this is negative and this is positive, that means both of my factors have to be negative. So it has to be, both of these would have to be negative. And since I'm looking for x to the fourth here, then both of these are going to be x squareds. So now I just need to decide, is it -2 and -3? When I multiply those together, I get +6 to the 4th. When I add them together, I get -5x squared. With these two, when I multiply, I do get this, but when I add them together, I get -6x squared when I add them together. So it's not going to be this second choice. Okay, so whether or not you build a box or you do CAB or whatever, these are the two factors that you've found that go inside. I will do a quick little box here for box method. First term goes in the first box, last term goes in the last box, and the two factors I found belong in the other two boxes. And then I begin to factor out GCFs from each column and each row. 2x squared, 3. Now this one is one of those special cases. We've got a negative here and a negative here, and we already decided way back over here when we began that this is one of those special cases that has a negative here and a positive here. So inside each parentheses, they're both going to be negative. And this is one of the rare occurrences where I get one negative in each spot and it doesn't usually show up. Usually I say don't factor out a negative unless both in the row or both in the column have a negative. But actually here, because of our special circumstances, these are both going to be negative. So let's write it out over here and then do a little double check. All right, now I'm going to FOIL just to do a check. So 2x to the 4th minus 2x squared minus 3x squared. That's going to be plus 3. Okay, so once I add this, so yes, so far so good. So far so good. I'm in a good spot. Let's get rid of all this and go back because yes, we are in a good spot. And yes, we do have something more we can do because take a look at this. This is a difference of squares, so I can continue factoring. It is not in its simplest form. So I need to go another step. This first set of parentheses is done. It cannot be factored further, but my second set is a difference of squares, so it can be factored further. And now I am finally complete. Okay, one more that looks like that. Let's do the next one over here. Look for a GCF in all three terms. There's not one. Multiply first or count. You have 1, 2, 3 terms. It's a trinomial. According to my flow chart, the trinomial, multiply the first and last terms together. I'm looking for two factors I can multiply together to get 9x to the 4th. And those same two factors need to be able to add together to give me -10x squared. So again, I've got a negative here and a positive for my last term. The only way that's going to work is if I have two negatives inside the parentheses. So both of the factors that I find, both of them are going to have to be negative. And that happens because when I multiply them together, I have to get a positive. And that's the only way to make that happen with a negative here. because if there's a negative here, that means I'm adding together things with a negative value. So both of these are going to have to be negative here. I need, let's see, 3 and 3 is not going to work. 9 and 1. Yeah, it's got to be 9 and 1. So 9x squared and 9x, nope. Just kidding. 9x squared and 1x squared. Multiply them together, and we get that. Add them together, and we get negative 10x squared. Okay, which is what we have here. All right, so since there's not a leading coefficient in the front of that trinomial there, then this one we don't have to have a box for, because I can just fill in the negative 9x squared and negative 1x squared. Okay, and so then I don't need these either. Just checking. All right, let's double check. So I'm going to do a FOIL check here. First, outer, inner, and last, positive 9. Add these two together. Okay, so this is what I had from the beginning. Okay, so I know I'm doing good. I know I'm on the right track. I just need to check my answer so far and see if anything else can be factored or if I'm actually finished. So of these two sets of parentheses I'm left with, can I continue to factor, or are they all done? This is a difference of squares. So this can be factored into x minus 3x plus 3. And actually, I have another difference of squares here. And so now it looks like I'm finally finished. Okay, so with higher order factoring, still follow your flow chart, but be very aware, because there's a good chance you're going to need to continue factoring before you think you might be finished. Okay, let's go back up a little bit and look at a couple of sum and difference of cubes, since those are considered higher order factoring as well. This would be the pattern for a difference of cubes. This is the pattern that will follow for a difference of cubes, and this one being sum. In order to have a sum or difference of cubes, you have to have two terms. Both of the terms have to be perfect cubes, meaning you can multiply them times themselves 3 times and get the term that's given in that spot. The only differences between the two patterns is the fact that difference of cubes is subtraction here and addition here. And if you have a sum of cubes, there's addition here in the first spot, and this is subtraction. So that's the only difference in the pattern. Starting with number 1, I have two terms. Neither of them have a GCF. It's subtraction. So I'm looking at the possibility of a difference of squares or a difference of cubes. So I look at each term. Is it possible to take the cube root of both terms? I can cube root this. The cube root of that would be x. And the cube root of the second term, yes, cube root of 8 is actually 2. So I can take the cube root of both parts, and that gives me my first set of parentheses in the pattern. The second set of parentheses, I'm going to take this term here and square it. And then for the middle term, I multiply the first and second terms together. So I multiply the x and the 2 together. And then for the last term, I take the second term here and square it. And that is it. Difference of cubes. Okay. Same thing, but sum of cubes. Only thing different here is that there's addition. So it's a sum of cubes. I cannot factor out a greatest common factor. I have two terms. There's addition in the middle. If both of these can be cube rooted, if you can take the cube root, then you will have a sum of 2 cubes. So let's start with the first term. Can I take the cube root of 8? Yes, cube root of 8 is 2. Cube root of x cubed is x. Can I take the cube root of 27? Yes, that is 3. So that's the first set of parentheses in my pattern. Now in the second set of parentheses, it says take whatever's in that spot and square it. So that means I take all of this and square it. So I'm squaring the whole thing. That's 4x squared. Next term says take this and multiply them together. 3 times 2 is 6x. Last term in the pattern says whatever's here, square it. And now you have fulfilled the pattern and you have factored your difference of cubes. Okay. Alrighty, lots of practice.